give you this file. Let's see, we can go function f equals new function f dot to string. So this is the function it came up with. And then we can go s dot run test f. Didn't see it, huh?
How quickly does it draw?
What?
How quickly does it draw in like every millisecond?
Shouldn't have been that fast. Let's see. Oh, that's oops. Wrong place. There we go. Try that again. So there's my F. Oh, it's a terrible one.
But it was random.
Yeah? No? Terrible. Ah, better.
I set it so that on the first one it always does binary.
Oh, okay, so you always get a function that has at least two in it, yeah.
It's recommended.
S dot run test F. So this is called a turtle, and if you ever programmed as a kid in a language called Logo, you might recognize the turtle from that. This is the target that we're trying to hit. It starts here, and it takes a step forward. Excuse me, it evaluates the function by plugging in how many steps it has taken. So at the very beginning, it hasn't taken any steps, so it plugs in 0 for that function, and whatever number comes out, it turns that amount, and then it takes a step forward. And then it plugs in the number 1 into the function, and out comes a number, and then it turns that amount and takes a step forward. Does that make sense?
Would you just
So
put
what
it
if
in
your
your graph
function
then?
doesn't have a variable?
What's that?
What if the function doesn't have a variable?
Oh, let's try that out. F equals new function, new constant, 5. What's he doing? So he turns 5 degrees, and then takes a step forward. Turns 5 degrees, takes a step forward. Turns 5 degrees, takes a step forward. So that makes a circle. How can you make a bigger circle?
Bigger number.
Take more steps.
Bigger number?
Yeah.
Smaller number?
Smaller number.
Yeah.
So
0, 0, 0, 0, 0, 0, 1.
Well, let's try 2.
still gonna take a step.
Yeah, give him like 1/50th or something, and then eventually he'll hit that.
1/50th, like 0.02.
0.02, yeah. Oh, I just missed it.
Wow.
Back in a minute.
Okay, let's,
So how
Put a
about
cup of coffee on it. What are you doing?
negative 0.2?
We just need to get him to
Slow
turn.
and steady wins the
we're
race.
gonna make it hit the circle. Let's just throw numbers in here.
It's the other way.
Negative 0.5.
Just do
Okay, so
0.2, not 0.02.
So here's a question for you. If your function produces, let's say, this as its output, so no matter what x you put in, you always get, 1.5 out. What shape does it make?
Circle.
Circle. If your function produces, let's say, this as its output,
Produces a parabola.
spiral. spiral, parabola.
It just looks like a line.
Yes.
So this says that when you plug in 0, you get, let's say, 1 out. When you plug in 1, you get 1 point, oh, let's say it's 2, right? Here, plug in 2, you get 3. You plug in 3, you get 4.
Inward spiral.
So every time he takes a step forward, he turns slightly more. So it makes a
Slope.
So you're going to take a step forward, and then turn some amount. Take a step forward, turn a bit more. Take a step forward, turn even more. So he's going to spiral in.
Until he gets to 360,
Well,
and then he's gonna start a new spiral.
No, then he turns 400 degrees, turns 500 degrees, turns 600 degrees. So he just spins in place.
So he's gonna keep adding 1, so he'll effectively be back to 1 at 360.
Right? But it'll spin a lot. It'll actually make a full turn, and then
Right. But it'll still start a new spiral.
we can try that here. We can go new variable x. Oh, that's far. What happened to my cursor? There it is.
Do the head
And
spin.
he actually moves around a little bit because there's some rounding error as he's spinning around. And so it doesn't quite make a tight spiral, it actually makes kind of a shape like that. Okay, so let's make another random function. Oops, not that one. Let's go. That's not good. Better. Oh, yeah. So after all that,
It still evaluates.
it just evaluates with a single number.
It's because you get a sign in there.
What's the sign do?
I don't know, I'm just blaming it on signs.
Actually, I think sign is kind of a problem. Well, it won't give you a constant, but it always gives you a number between
Negative 1, 1.
-1 and 1. So no matter how big a number is that comes in, it always winnows it down to just something that's really small. So I kind of think that maybe sign isn't, I mean, it makes fun looking plots on your plotter, but as far as the robot goes, it's not great. Which is why I didn't add cosine and all the others here.
Factorial.
Anyway, so now that I have this function f, I can now go f.mutate. I need a, let's say, point 1. So there's a 10% chance that the numbers in here will change.
It looked like it changed.
Let's do that again.
It changed.
It changed, right? Well, this f.replace, well, first of all, we can go f.count, and that tells us how many terms are in this function. So pick a number between 1 and 36.
36.
It's it between?
25.
25. So f dot replace 25, and let's replace that with some new random function. So we'll go to term number 25 in the expression and swap that with another function.
So you just infected this thing with a virus.
Yes.
Now it's going to be a zombie.
This is not natural mutation then.
It's a zombie turtle. See, there he goes. Turtle brains.
Oh, we can do a mutate on that, run that test again. Oh. Give me another number.
4.
4. Oh, he does a little dance. So anyway, so I have this function here called run test, which is this one here. You give it a function, and then it creates an array of points to keep track of where the turtle went on its little journey. And I also have an array of targets, and right now there's only one target in that array. I paint an oval on the screen where that target is, which is right here. Then I set down my turtle, starting at 300, 200, which is this spot here. I set his speed to 0.89 so that we can see it on the screen, and I, through trial and error, have arrived at that number. You give it a number between 0 and 1. 1 is full speed, and 0 is barely perceptible movement.
Watching paint dry.
Yeah, grass grow. And then I just count from 1 to 1,000. I add the current location to the path, which is the points that the turtle's been on. Evaluate the function, turn that amount, and go forward 1. Just repeat. And then I have a function called fitness. And what that fitness does is it calculates the, so if I have a target here, and, well, I'll do it on the screen here. If I have a target here, and I've got a path, like this one here, it loops across all the points in the path using the distance formula to figure out how far from the target it was at any given point. And then it figures out what was the closest it ever got. So for the one that did this little dance over here, the closest it ever got was its starting point, and it actually got further away. But this one here probably actually got a little bit closer. So we might want to keep this turtle and throw away the one that danced. So then I got another function here called, let's see, where is it? Run tests. You give it an array of functions, and then it just runs each one of those, figures out if that was better than anyone I've seen before, and returns the best one. It also happens to just bail out if I actually find one that just, finds the target. If there's one that finds a target, there's no point in testing any other turtles. I've got a good one here. And then finally I have one called do it all. It generates 100 random functions, runs them all, figures out which one was the best one, keeps that one, and then from that, random replacement, like I just showed you, does some random mutation, guarantees that I always end up with a function that has at least 2 things in it, kind of like what you did, and then does the whole thing again. And I also want to, so let's watch that here, but actually what I want to do first is I want to set the speed so it goes faster.
No.
Yeah, trust me.
Well, we like seeing the turtle.
Yeah, 0. to see will I see the turtle at least once in a while? Oh, just like sleep.
Yeah. Because we've got tens of thousands of these to do.
I can start off. That's gonna get it right first time.
Oh.
Okay, so it's trying 100 turtles, trying 100 functions.
We don't get to see the turtle.
It's going so fast.
There he is.
There.
That turtle died.
He had a heart attack.
Oh, we found one. So after only 2 tries, it came up with a function that could get that target.
2 tries at one.
Well, 2
Okay.
cycles of 100. So after the first cycle of 100, this was the one that came up within 32 pixels of the target. So it used this one as the basis for the next generation. You can see the next one here actually looks pretty similar. It's just this piece here that changed, right?
I told you it was that sign.
And this is a conditional pair. The conditional takes 3 expressions, one here, and one here. It evaluates the first expression. If that comes out to be more than 0, it evaluates the second expression, and if it comes out to be less than 0, it evaluates the third expression. So it's a simple if-else. Should we try it again?
Mm-hmm.
Bunch of turtle poop in the middle there.
Found it.
Oh, found it.
But it didn't touch it.
Yeah.
Well,
It's
I said
something
within
that's
5.
5 pixels.
Get within 5.
Try 0.
Try 0. Yeah. Try 0.
Like exact.
We'll be here forever. This guy hit it exactly on the nose.
That's
Okay,
the best
within
part.
2.
Within like
Obviously,
0.5.
5's too big. It's not even touching.
I'm gonna try
0.5.
0.5. I need to make a constant here so I can change these things quickly.
Within half a pixel.
Let's go with 2. There's 2 places I have to change that. I don't like that one there. So now we're on the second cycle of 100. This was the best one it found so far.
Got it. Whoa.
What happened?
Oh, look at those.
It's just going right through it.
I guess we gotta do 5.
4, 5.
Oh, I found it at 0.02. Okay.
Oh, it's done.
Yeah.
It's happy.
Yeah, I'm not sure why I ran through that whole set of 100, but it's a little bug to fix. But yeah, we got one pretty close. Okay, so it took, what, 3 kind of cycles through to find that? Oh, no, sorry, about 5 or 6 of them. So let's go and add another point. It's got to hit both of them.
What?
Alright, maybe 5 would be
Make it
good.
to 5.
Put back to 5.
Yeah,
You need a constant. Well, what if we ran it at full speed? Would it just like try and then finish, try and then finish? Or we wouldn't even see
Well,
it?
let's crank up the speed on this.
it's good at that.
How's he gonna hit both of those points?
It's in a straight line, too.
with the same function?
Yeah.
Got one.
Blast that.
So last night I was doing this and I found,
Yeah, that one.
it finally came up with one that went like.
So when it evaluates fitness for multiple points, does it evaluate it based on an average fitness of both points, or does it?
It finds the closest it ever got to each one of the points and then adds those two numbers together. But yeah, it should probably do an average, because if we want to do less than 5.
It amounts to the same thing.
Because we're doing less than 5, but let's say it got within 3 of one and within 3 of the other, that's not good enough. Because it adds it together and gets 6.
I don't think it's gonna do it.
You get stuck.
Do it.
It's doing a lot of straight lines.
Are they straight lines or just really big circles?
That's true.
Looks straight.
Did a good alternating one about a couple thousand ago, but it went down instead of up.
Yeah.
Should've-
Like we were way back.
Yeah, it was going like this. Would have worked if it could just get it in the direction.
So is this thing learning, or is it just random the whole time?
Well, it's sort of random in that it's just generating new functions to stick into the expressions. What I really want to do is do things like find the turtle that goes best, and then sort of like replicate pieces of itself. So take part of its subtree and kind of swap it for another location and part of its subtree. Or I might want to do something like take the 2 best turtles and start swapping their pieces around, or mutating their pieces. Just do a lot of mutation of the numbers to see if you can kind of get it a little bit closer to where it's supposed to go.
So it's like a nature simulator, survival
Yeah.
of the fittest.
Yeah.
Seems like it's just trying a bunch of lines in between the two.
That gets you pretty close to hitting both of them, doesn't it?
Yeah, but it's not going to hit both of them.
It doesn't know that.
Or you could just be up to 10.
It's a computer.
What? Is it? Is it fastest?
This is as fast as it can go. If I took out the drawing entirely, it could go a lot faster.
Really wouldn't know.
Oh, there's
Oh.
that one, starting curve.
You could probably set it to just draw the best turtles out of each batch.
Actually, it does. If you look closely after the screen clears, there's a green path that gets drawn. That's the best one it's found so far.
I just meant like only draw that one, so it doesn't
Yeah.
have to spend as much drawing time.
So the green one is the best one it found so far, but then what happens is it does a mutation on that one, and you end up with one that's just slightly different, and it gets overdrawn with a black one. So you gotta look quickly, and a green one does appear for a brief moment, and then it gets overdrawn. Yeah?
So how complex is it to do something like where it would see a curve or something, a pattern that it likes that's in the wrong direction, but changes it to
It wouldn't.
angles?
It wouldn't.
Could you do it that way? Or could you figure out how to do it?
Like if one's the furthest away,
Mm.
well, do the inverse of it.
Just create.
Just let that particular genome die. I mean, you kind of think about it as maybe ants that are foraging for food, and those are 2 little piles of food it's trying to get to. And if you've got an ant that insists on always going the wrong direction, you might as well just kill that ant. Don't let it reproduce. Go for the ones that aim in the right direction, rather than trying to put some smarts into that ant saying, hey, you're going the wrong direction, why don't you turn around and go the other direction? Because all this stuff is just happening randomly, and you're just as likely to stumble across one that happens to go in the right direction in the first place.
And now we know why there's millions of ants in every generation.
So this seems like it'd be a good way to create best fit lines for like statistics and stuff.
Yeah.
Get
if I could just work on the part that does the mutation and the replacement so that it's better, because right now we get ones that are kind of aiming towards those dots, but we also get a lot that are going.
They're not
They're
straight,
starting to curve now.
Starting to curve now.
Yeah,
Yeah, they're swiveling, man.
Mutations.
This is what we need those.
we're getting close. I think it's gonna happen.
Just gonna find one.
I'll find it eventually. Look at that, see, that one's really close.
Starting to see the
Can I
curve.
just wait till we get 7 points up there?
I'll go bathroom, go bathroom.
How much longer you want to wait on this thing?
So I wanna see it
Until it
finish.
finds it.
Just start lecturing and just let it go as you lecture.
This is our class.
That's why they need multiple.
And then when you hear us go, yay, then you know that we weren't listening up to that point anyway. We're watching that, but.
What's the deal with you only doing one discrete structures class for fall?
What's the deal?
Yeah, what's some of that?
He always does one. Just one.
One is not a very good time.
One is not a good time
The time you have doesn't work.
For you.
for you. What time is it?
It's like 11 to something.
It's the time it's always been.
There's a lot of good math classes and stuff that time. You're the only one that teaches it too?
Mhm.
You should take it this year, man.
Should have switched my major.
So what? Math?
Pretty close.
English.
He's become a math major and he's got it. He's like,
Engineering.
Oh, today's lab day, right? Did you guys see the announcement?
Have that.
Eclipse? Eclipse, yeah.
oh, we should download
So we do have Eclipse installed on, well, the computer's in the lab, not this one. Let's see. Away. Do I have it here at all?
It's like they're
No?
Oh, you could type in Eclipse and see if it came up.
Oh, that's an old version. Don't need that. Old version.
See, then he's gonna find out it's not available for download, and that was the last big copy. He's gonna be like, man, I wish I had that somewhere.
It's in his trash can. Oh, that's another thing I don't like going and say, where's my trash can? Where's the trash can? I wouldn't use it.
It's there.
They don't have one, you just go to the old tablet in the trash can. Like, I don't need this, I'll just go buy a new one.
It took my start button.
So we have Eclipse installed in the lab, but it's a slightly older version, so I recommend that you download and install your own version for a couple of reasons. One is it'll be the newest one, and two is you'll be able to install your own plugins to it. Like if you want to use something other than Git to do your file versioning, then you can install that plugin. If you want to do Android development, you can install that plugin. So I recommend getting a flash drive or using your laptop. If you want to use a flash drive, get a fast one. I like these Kingston ones. You can get an 8 gig one for about $10. This is a 32, so it's probably $30, $40.
More than $10.
You know, the 2 gig one will be fine if it won't exist anymore. You can get them at Fry's. So you guys know that flash drives do come in different speeds?
Yeah.
They're not ranked like a SD card is the like class 10, class 4.
No.
So it's kind of confusing.
It's kind of hit and miss.
Yeah.
So what I usually do is I look on the package, and if the advertiser, if the manufacturer actually tells you what the speed is, says, you know,
That's a
read
good start.
speed at 11 megabytes per second and write speed at 8 megabytes per second, those are pretty good numbers. I mean, they're not as good as a hard drive, and they're not as good as an SSD, but they're good for cheap flash drives. However, if the manufacturer says up to 50 megabytes per second, What they're really telling you is theoretically it could go that fast if it was pushing the data at the full USB speed.
And sequential.
So that's like when you order, you know, a combo meal and you get up to a full bag of fries.
Right. In
Might get one
theory,
fry.
that box holds, 50 fries, but you might only get 30.
Or two.
Or yeah, you get furniture sales, up to 90% off. Most things are 5%, but up to 90%, right? So in a flash drive, here's your USB connector.
90% off the basic dead flowers.
There's usually 2 chips in there. This is the flash memory, and then this is called the controller.
And the bigger they are, the faster it is, right?
Sometimes. Because physically, the bigger they are, it means that they can put more data lines between the controller and the flash memory. So they can move data in parallel faster. If you get a really small one, like the ones that look like the mouse, you can
That's
get ones
a
that are,
wireless thing.
yeah, but you can get ones, flash drives that are that big, smaller.
Those tiny little Patriot ones.
Yeah, USB here, and there's just little things sticking on the end. So they probably have a controller chip here and a flash chip and one serial line going between them. So the controller chip's job is to shuttle data between the USB port and the flash memory, and you can spend more and get faster controllers, and you can spend more and get faster flash memory. Anyway, so I like the Kingston ones, they're pretty fast. The no-name ones that say up to 50 megabytes per second probably are lying to you. Or I should say, telling you the absolute truth. It's kind of like all the rage back in about 10 or 15 years ago was to stop telling you how many pistons were in a car and tell you instead how many valves there were. It's a 16-valve car. Okay, there's 4 valves per piston. It's a 4-piston car.
By the way, it's a huge
About
pain
30
in the
valves.
ass when you have to work on it.
Wait till you get to the 24 and 32 valve.
Okay, so you can download Eclipse. You can go to the Eclipse website, which is eclipse.org, and download it that way. However, if we go to the lab and 20 of you all download Eclipse at the same time, and the download's about 150 megabytes,
It'll be awesome.
I was getting half a megabyte download when I was installing it through apps, so through repositories.
on campus here.
Yeah.
So you're fighting with everyone else on campus trying to download stuff, and so all of you are sucking down the 150 megabyte files. You're going to be waiting a very, very, very long time. So I downloaded them to our server here. So if you download them from these links here, they're just coming from upstairs, and they should go pretty quick. So you need to pick the appropriate version for your operating system. There is actually a 32-bit Mac OS version as well, but all Mac is only running 64-bit now, so I didn't post that one. But you do need to get the Windows 32 or Windows 64. And if you're running Linux, you can probably just use your package manager to get Eclipse that way, or you can go to the main website and they have a link to probably your specific distribution on there.
Tarball.
Hmm?
They have a tarball.
Yeah. So I'm running Windows 32-bit, so I'm going to download that one. Here it comes. Boop, 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 boop. Boop, boop, boop.
Dude, that's going mega fast.
Is it done? There.
Mine's about it.
And then I'm just going to put this on my desktop. This is the part that takes a while.
How's the turtle doing?
It's got to unzip.
Did we get a line yet?
What?
Did we get a line with
Yeah.
this bit yet? We're waiting for this to.
Close that. Close that.
Nope.
Still going.
Last circle.
21
Looks
now.
like it's hitting.
It's down
just
from
not
32.
registering.
It's getting a lot
What?
closer.
It's not hitting both at the same time.
No, it
Yeah.
is.
No, it's not.
No, it's not.
It's in 5 degrees and it's.
So that was the best one right there.
So it's
Yeah, we're to really think that's really close.
shredder?
How evolution works, sometimes it's fast, sometimes it's really,
What we gotta work on is the way it does its mutation, because there's too much randomness in it right now. It's not really, I mean, it does start with the best one so far, but then,
It just goes crazy.
it just creates all sorts of random ones from there. What we need to be doing is taking that best one and just tweaking little things so we can get it a little closer to where it's supposed to go.
Is it mutating the function or is it mutating the values, the constants?
It finds a random spot in there, replaces that with a whole new function, and then mutates with a 1% chance.
Okay.
Which means that at least one of them mutates every cycle.
Well, every number in there has a 1% chance of changing. So if there's 100 numbers in there, chances are one of them is going to change.
At some point, we could actually go away from it being a best fit line if we just start going in a random direction again.
15 minutes.
What deep are you going per function?
20?
So like if you had a 20 long function and you said, hey, this right here, we'll just replace another 20 length.
Yeah, well then those can go deeper. But when it generates a random function, whether that's the original one or one to slip in there, it limits it to 20. So actually the overall function can grow and grow and grow.
That's what I'm saying, like my computer crashed. When I try to go 300 deep, it crashed.
Don't go that deep on your first function. 50 minutes, huh?
It crashed or?
50 minutes.
Okay, so while we're waiting for that,
Because my blue jay just locked up, it just went, I'm done. So I didn't.
It's too much.
Go on release.
so let's talk about the function that does a replacement. And so the idea behind replace is identify a random spot in this tree. And so